Okay, so we are doing all of lesson 1 for this video. Pay careful attention, it may end up being in multiple parts. So you should be on lesson 1, day 1. Go back through, double check all your work if you already have it, and if not, make sure you're getting it copied down. Our goal is to understand the nature of a function. So a function will map a number from the domain or your set of x's and inputs into another set called the range, which is your outputs or your y values. And we'll practice set builder notation from there. Okay, so you can see a function is a correspondence between two sets x and y, in which each element of x is matched to one and only one element of y. So the inputs of a function must uniquely map to one output, or meaning you should only get one answer out. So if we look here, there's one line coming out of the 2. One from the 3, one from the 4, one from the 5. This is a function. It is okay if you repeat your y values or your outputs, but you should never see a repeating x. So over here, where you see that the 5 gave you 2 different answers, that means it failed. That's not a function. We shouldn't ever get 2 answers, at least not with a true function. For the domain, remember domain goes with the x, so domain goes with x, and then the range is referring to the y or the outputs. So x is what I'm plugging in, y is what I'm getting out from my answer. And we create a set of input values for the domain and then a set of output values for the range. And what you should notice, domain and range are in alphabetical order, so are x and y. So you can remember that they go together alphabetically. And in function notation, traditionally a function is referred to by a letter name like f, but they can be referred to by like any letter from the alphabet. And this notation is thought of as being another way to represent like y equals. So it's just kind of like a fancy y equals. So it's read as f of x. And what is inside the parentheses tells you what the input is. And then the whole thing is your output or your fancy y. So when it comes time for your table, like in your calculator, if you wanted to work with this, let's say like this h of a function right here. If we go to the calculator, the y equals is the h of a equals part. Then basically I'm putting it into my calculator the exact same way as we always did. It's just I'm putting x in place of a. So I see h of a equals a squared plus 5a plus 4. So I start with the a squared. Instead of a, I use x, and I need to square it. Then plus the 5a, and again in place of a, I just put the x, and plus 4. Now I'm ready to work with it. When it comes time for the table, so a is on the inside of this function. It says h of a with a on the input. So that means it goes with the letter x in my calculator. X's are my inputs. I can consider this my a column. Then the h of a, the whole notation, is the fancy way to show the output or y values. So this y1 column becomes the h of a. So you look at it and work with it, same as we always have, it just looks a little different. Looking at the next page. So we're going to start with understanding some of the domain and range stuff. It's a little bit tricky at first, but you'll start to get it as long as you just kind of stay with me. And if you're having questions, you need to come to see me and make sure we're getting them answered. We're going to practice actually doing the whole domain and range properly instead of trying to learn it one way and doing it another after that. So this first part, we're filling out the table and completing and answering the questions. So to fill out the table, what you need to do is show how you would plug into this function every time. So like my input of 1 says anywhere I see an x, I need to replace it with a 1. So I'd have f of 1 equals 2 to the first power. And I need to go figure out what that is. So I could go to my calculator and I can, each time using whatever follows equal sign, plug in my x and go get my answer. And so that's what we'll do on the first one. So 2 to the first. That's 2. Output is 2. Then I have f of 2. So again, wherever I'm seeing an x, I'm just replacing it with whatever this input value is. So then I need to evaluate 2 squared. So I get 4. And f of 3. now it's 2 cubed. Gives me an 8. And 2 to the 4th is going to end up being 16 if we evaluate it. And 2 to the 5th will be 32. So what I showed in class and what I will show you here is that you can do this all and show all your work very simply. The short way to do this is to still show me how you might plug everything all in right here. Just like I did, just run through, fill them out. It takes no time. Replace all your x's with each of the input values till you've got the whole table filled out. Then what we would do is utilize the calculator as a nice tool that works to our advantage. So again, we're coming to the y equals, make sure it's all clear, and then put everything that is to the right of the equal sign in. So my function says 2 to the x. So I would put that in, go to my table. I am evaluating 1, 2, 3, 4, and 5. So at 1, I see an output of 2. And then I would go over here and write it. And at 2, I see an output of 4. At 3, I see the 8. 4, you saw the 16. And 5, you saw the 32. So it's the same amount of work that's being written down. It's just a lot less for you to actually do. Now as far as the domain and range of this function. If f of x equals 2 to the x is a function given by evaluating expression 2 to the x for the number x, what is the domain of the function? So right here is the key thing. What is the domain of this? For the domain and the range, what we're actually doing is we're trying to figure out where does this function exist? How can we script out a way of describing what the graph looks like and where it exists? So anytime we see errors in our table or places where the actual graph does not exist are the places where we would have to actually restrict the domain and the range. And we'd have to say, like, oh, but it only exists here. So when we take a look at it, you can see the picture that was on your notes, and then up here, it doesn't show it good in the calculator. This is an exponential function and it continues, like it gets right up against the x-axis but doesn't cross it. Continues up and it continues out. So I have to describe that. As it is going up over here, you will know it's also going outward. And like, again, down here, it approaches the x-axis, but it doesn't ever cross it. So you'd see in the table, if we go back to looking at the table, that my function will get really, really close to 0. We start seeing it get smaller, 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 closer to 0, until eventually it has to use scientific notation. So it's never going to equal 0. And I can see here the numbers are going up. It's always going to be bigger than that as far as what my answers are concerned. So when I come to do the domain and the range, we always start with a fancy little symbol. It's like an R with 2 lines. This says all real numbers. It just allows you to say that without having to write it out every time. And then you have to decide, do we need to restrict? And if we come back to that graph that I had, I remember I said it comes this way and it just keeps going, and comes this way and just keeps going. It's going up and out over there. So that means there's no restriction for the domain. I can plug any x value inside of it, and I'm going to get an answer. They're either going to continue to get smaller forever and get really close to 0, or they're going to continue to get bigger forever and approach infinity. So I'm done on the domain. I don't have to add anything else. It's just all real numbers. I can plug anything in. But for the range, when we go back to look, I start with the all real numbers, and then I put the comma to show such that. So this is around all real numbers such that, and now I need to identify that restriction. So again, we said it came really close to 0 here, but never was equal to 0. And then it goes up forever, approaching infinity. So I show that to show that I'm getting bigger than 0. I have no equal sign because I never can equal 0, and now I'm done. So it's saying it's all real numbers as long as your y is greater than 0. And so I've identified this picture. Where does it exist? How does it look? So from here, I want you to practice again filling out the table. Plug in your inputs and show me how you plug it in this middle column. Write down your answers, and then we'll check it and talk about the domain and range. So pause the video here. All right, so after plugging in everything, you should have found this table. And when we take a look at our function and see what it looks like, you will see that it has a picture. If you didn't already recognize it from the equation, you see this picture. You can see it's a line. By the nature of a line, we know that it continues forever in both directions. So what I'm seeing is that it's continuing to go out to the left and out to the right forever. I'm also seeing that it's going up and it's going down forever. It's doing both at the same time. So with that being said, if I am continuing to go out to the left and the right forever, always getting an answer, I start with my all real numbers and then there's no restriction. I see it going left and right forever. And then again, at the same time, it was also going up and down forever. It was a diagonal line. So again, I start with the all real numbers, but then it's just continuing forever. I don't have to make any restriction. If we had just a vertical line or we had just a horizontal line, then we would have to make some restriction. But as it stands, we do not. So again, with 3, I want you to do the same thing. Pause it, fill out your table, and see what you can kind of come up with for ideas for the domain and range, and we'll go over it. All right, so again, you should have plugged in. I rounded to the nearest thousandth since I didn't tell you ahead of time. If you did not, that's okay. And then as for this function, we need to determine the domain and the range. So we should look at our graph to kind of give us a helpful place to start. And if you don't have to, you can also do it off of the table. What I see is it's sitting there in that first quadrant. I'm just seeing right nice right here. It's starting and it's going and continuing forever. That's the nature of the square root. You also have, if you look into your table, you can start to see those errors in the graph. I need to describe that for my domain and range. So again, I describe it exists everywhere except, because again, we saw it only in a certain spot. For what x values did I see it? You can get it from your table or from your graph. I start seeing answers here at the 0, and then it's getting higher from there. So for any x value greater than or equal to 0. Then for my range, again, all real numbers, but I need to show how it only exists in that first quadrant. So I look, and that's all right here again. So my first answer here is 4, and they're all getting bigger from there. So again, I say all real numbers such that y is greater than or equal to 4. And now I have shown and done the necessary description to show that it is in the y1 column. All right, so this is the end of this video and what is happening for the first day. I'm going to have you do question number 4 for homework, and you'll be able to follow up and check your work on it in the next video. All right, so you're seeing this is part 1. The next video will continue from here and be part 2.